So if you've ever tried building, those really sophisticated AI apps, the ones using LLMs, handling all sorts of inputs like audio and video, and needing to be super responsive in real time.
Oh, yeah.
It can feel like assembling this incredibly complex puzzle, right? You're always kind of stitching things together, data processing, API calls that might not return right away, custom logic.
Exactly. And as it gets more complex, the code just gets, well, brittle,
Hmm.
really hard to maintain. It just eats up development time.
Right.
And that's really why this new announcement from Google DeepMind is pretty significant. They just rolled out Gen AI processors.
Gen AI processors, okay.
Yeah, it's a new open source Python library, and it's specifically designed to bring some structure, some simplicity to exactly those challenges we're talking about.
Okay, so how does it do that? What's the core idea?
Well, its main job is to give you this abstraction layer,
Yeah.
a consistent interface, they call it a processor, for pretty much everything. Input handling, pre-processing, those complex model calls, managing the output, all of it.
Oh.
So think of this deep dive as your kind of shortcut to figuring out how you can build these powerful, flexible Gemini applications, but, with a lot less of the headache.
Okay, I like the sound of less headache. So let's unpack this. The sort of secret sauce seems to be how it deals with data. It treats everything as asynchronous streams of processor parts.
That's the core concept, yeah.
When I saw that term processor parts, I immediately thought, okay, what is that exactly? And how does using streams actually make things simpler? Seems almost counterintuitive at first.
That's a great question.
Yeah.
Think of processor parts like standardized data packets, maybe like Lego bricks for
Okay.
your data flow.
Okay.
Each brick holds a specific piece of info. Could be a bit of audio, could be the text transcription of that audio, maybe a frame from a video feed. And it travels through your pipeline with its own metadata, like a little label.
Right, content.
Exactly. And this stream-based approach, especially the bidirectional streaming capability, that's what makes chaining things together so seamless. You can just connect different steps, data tweaks, model calls, whatever, almost like snapping those Legos together.
That makes a lot more sense. Snapping Legos is definitely better than wrestling with brittle code. And I noticed you mentioned optimization. It's not just about structuring the data flow.
No, not at all. What's really fascinating here is how the library is built to optimize the concurrent execution of these processors.
Concurrency. Always tricky.
Right. So when you apply a processor to an input stream, the system automatically figures out how to run things in parallel as much as possible.
Okay, so for someone who's built these kinds of pipelines manually before, what's the big win there? What jumps out?
The absolute game changer is how it minimizes that time to first token, the TTFT.
Yes. TTFT.
Crucial. It gets that first bit of output back to the user faster,
Uh-huh.
but, and this is important, while still keeping the order of the final output stream perfectly correct.
How does it manage that?
Well, essentially, any part of the process can run as soon as its inputs are ready.
Mm.
But it ensures, say, the audio transcription for a moment doesn't show up before the video frame it's describing. Everything stays synced up.
When this happens
Automatically. It's
Yeah.
all under the hood.
Yeah.
You don't need to mess with complex threading or manually build processing graphs.
Yeah.
The library handles that optimization for you. Makes your apps feel incredibly responsive.
Okay, that time to first token reduction alone sounds massive for user experience. But let's talk practical examples. The live agent examples caught my eye. Processing audio and video in real time looked way simpler than I expected.
Absolutely. And that's addressing a real growing need,
Yeah.
We need more proactive LLM applications where being responsive isn't just a nice to have, it's essential.
Right.
With Gen AI processors, you really can build a live agent using the Gemini Live API with just a few lines of code. The way you combine inputs and steps with a simple plus operator like misinput, plus one processor, plus speaker output, it makes the data flow super clear.
That's very intuitive.
It is. And even if you're not doing full real-time streaming, processing data chunks as soon as they arrive still cuts down latency significantly, which, again, is key for a good user experience. Plus, that bidirectional streaming means you could even build your own live agent with a standard text LLM and something like the Google Speak API. It's flexible.
So if we kind of pull all this together, what does Gen AI processors really mean for developers building these AI apps? What are the core ideas behind it?
I'd say it boils down to three main design principles. First, it's very modular. It encourages breaking complex workflows into smaller, self-contained processor units.
Like functions, almost?
Kind of, yeah.
Yeah.
But specifically for these pipelines. This makes them reusable, much easier to test, and simplifies maintenance hugely. fewer late-night debugging sessions.
Always a plus. Okay, what's second?
Second is unified multimodal handling. That processor part wrapper we talked about acts like a universal translator for data. Text, images, audio, JSON, whatever. Handles all these diverse types consistently within the same pipeline.
Okay, so no more custom code for every single data type.
Exactly. And third is extensibility. It's designed to be easy for developers to create their own custom processors. So if you need special logic or need to call out to some external API, you can integrate that smoothly right into the pipeline.
Right. Makes sense. So really, it sounds like GenAI processors is taking something that was often incredibly complex, building robust, responsive, multimodal AI, and making it genuinely approachable.
That's the goal. In a nutshell, yes, it simplifies things significantly.
Okay.
And if you connect this to the bigger picture, it really opens up possibilities.
Yeah.
Getting started is simple, just pip install GenAI processors.
Good to know.
Yeah, and the GitHub repo have collab notebooks. Examples like a research agent, a live commentary agent, good stuff to help you hit the ground running.
Great resources.
We really think this library lays a solid foundation for tackling these tricky workflow and orchestration problems in AI. So the question for you, the listener, is, with this kind of simplification, what sophisticated responsive AI systems could you build now? Systems that maybe seemed too complex before. What possibilities does this unlock for you?